Mastering ETL processes. To avoid data disaster, you must revolutionize your ETL processes to conquer big data. Which strategies and techniques should we employ in our ETL processes to effectively handle and process large volumes of data, such as big data, and ensure high-performance processing? When dealing with large volumes of data, such as big data, in ETL, extract, transform, load, processes, it is essential to employ strategies and techniques that ensure high-performance processing. Here are some strategies and techniques that can be used to effectively handle and process large volumes of data. 1. Distributed processing. Break down the ETL process into smaller, independent tasks that can be executed in parallel across multiple nodes or servers. This approach, known as distributed processing, can significantly improve processing speeds and scalability. Technologies such as Hadoop, Spark, and distributed relational databases, DRDB, can be used to achieve distributed processing. 2. Data partitioning. Divide large datasets into smaller, more manageable partitions that can be processed independently. This approach helps to reduce processing times and improve data locality, reducing the need for data movement and minimizing network latency. 3. Data compression. Compress data to reduce its size, making it faster to transfer and process. This is particularly useful when dealing with large datasets that need to be moved between systems or processed in parallel. 4. Column-oriented storage. Use column-oriented storage systems, such as Apache Parquet or Apache Cassandra, which store data in columns instead of rows. This approach is particularly useful for analytical workloads, where only a subset of columns are required for processing. 5. In-memory processing. Use in-memory processing technologies, such as Apache Ignite or GridGain, which store data in RAM instead of disk storage. This approach can significantly improve processing speeds, as data access is much faster from RAM compared to disk storage. 6. Parallel processing. Use parallel processing algorithms and frameworks, such as Apache Spark or Apache Flink, which can split data processing into smaller tasks that can be executed concurrently. 7. Data caching. Implement data caching mechanisms, such as Redis or Apache Ignite, which store frequently accessed data in memory for faster access and processing. 8. Data pruning. Remove unnecessary data, such as duplicate or irrelevant records, to reduce the overall dataset size and improve processing efficiency. 9. Data aggregation. Aggregate data at the source, such as in the database or file system, to reduce the amount of data that needs to be processed. 10. ETL pipeline optimization. Optimize ETL pipeline designs to minimize data movement, reduce processing stages, and eliminate unnecessary data transformations. 11. Real-time data processing. Implement real-time data processing architectures, such as Apache Kafka or Apache Storm, which can handle high throughput and provide low latency processing. 12. Scalable architecture. Design ETL architectures to scale horizontally, adding more nodes or servers as needed to handle increased data volumes or processing demands. 13. Data lineage. Implement data lineage tracking, which provides a clear understanding of data origins, transformations, and movements across the ETL process. 14. Data quality. Implement data quality checks and data validation rules to ensure data accuracy, completeness, and consistency throughout the ETL process. 15. Monitoring and debugging. Implement monitoring and debugging tools, such as Apache Airflow or AWS Glue, which provide real-time insights into ETL process performance, data flows, and errors. By employing these strategies and techniques, organizations can effectively handle and process large volumes of data, ensuring high-performance processing, scalability, and reliability in their ETL processes.